Every time you write a class, you are building a blueprint. Each object you create from that blueprint gets its own private copy of every field you define. That is exactly how it should work most of the time. But sometimes you need data or behavior that belongs to the class itself, not to any one object. That is the problem static solves. In this video, we will walk through why static fields and static methods exist, where they live in memory, when to use them, and when to leave them alone. Imagine a counter class. You create 3 instances, counter 1, counter 2, counter 3. Each one has its own count field, which is fine, but now you want to know how many counter objects have ever been created. You might add a total field to track that. The problem is that every object gets its own copy of total. When you update it on counter 1, counter 2, and counter 3 know nothing about it. You have 3 separate totals, none of them correct. This is the core problem that static is designed to fix. Understand why static works, you need to know where your data actually lives at runtime. Local variables live on the stack and disappear when a method returns. Object fields live on the heap allocated fresh for every new instance you create. But there is a third region, the class area, sometimes called the metaspace. This is where the JVM stores the class definition itself, its method bytecode, and critically its static fields. When the JVM loads your class, it allocates exactly 1 slot for counter.total in the class area. All 3 of your counter objects point at the same class, so they all read and write the same slot. Adding the static keyword to a field tells the compiler and runtime that this variable belongs to the class, not to any object instance. Without static, every new counter gets its own copy of total, starting at 0, forever out of sync. With static, there's exactly 1 slot for counter.total, created when the class is first loaded, shared by every instance ever created. You access it through the class name directly, counter.total, not through a variable. This is not a shortcut. It is the correct model. The field does not belong to any object, so you should not access it through one. Static methods follow the same ownership rule. A regular method receives an invisible this reference, pointing to the specific object it was called on. A static method receives no this at all. That means it cannot read or write instance fields because there's no object to read them from. What it can do is operate on its arguments and on other static members. You call it through the class name, mathutils.add, not through a variable. This makes static methods ideal for pure utility functions that depend only on their inputs and carry no state of their own. Static shows up in 4 common patterns. Constants, a value that is the same for every object like pi or a maximum user limit, should be static final so it exists once and never changes. Factory methods, a static method that constructs and returns a new object, giving you control over creation logic without exposing the constructor. Utility classes, a class full of stateless helper functions, the way math works in Java or math in Python. And the singleton, a private static field holding the one and only instance of a class, enforced by making the constructor private. Static is powerful, but it comes with real trade-offs. The 2 biggest are testing and concurrency. A static field is global state. Global state is hard to isolate in a unit test because every test shares the same slot. Static method that depends on a static field cannot be swapped for a mock. On the concurrency side, 2 threads updating a shared static field at the same time will race unless you add synchronization. Static also breaks polymorphism. You cannot override a static method in a subclass the way you can override an instance method. For anything that needs to vary per user, per request, or per configuration, reach for dependency injection instead. Static is the answer to one specific question: does this data or behavior belong to the class as a whole or to individual objects? If the answer is the class, use static. If the answer is the object, do not. That single question covers constants, utility functions, factories, and singletons. It also tells you when to stop. When you find yourself bending your design to make something static because it is convenient, that is usually a sign that your architecture needs a rethink. Thanks for watching.